Hello and welcome to a Good Design as Good Business series briefing. Our topic today, Principles of Unit Testing. And my name is Roger Snook. I'm your host today. I'm with IBM Software Rational Group, one of the worldwide enablement leaders in our OSD team. And you can reach me at any one of the information bits above on the slide there. So feel free to contact me on any one of those channels. Our speaker today is Ken Brittain, and I've known Ken for a long time. He's a programmer analyst at CSC, Computer Sciences, and you can reach Ken at any one of the two mechanisms he provided there. And this is actually a 3- or 4-part series that we're going to be running over the next few Fridays on this topic. So we would welcome you to invite your friends or colleagues that would also find some value in this series. Today's presentation, along with the other presentations in the series, are being recorded and will be posted to the Good Design as Good Business site on DeveloperWorks. So if you don't have that, you should be able to click on that link there in the slides and be able to get to that. I will also post that same link here in the chat portion of the window momentarily after Ken gets started, and you'll see that little chat bubble on the right-hand side, way over on your right-hand side, to the right of the attendee list. And with that, let's go ahead and introduce our agenda for today. So our agenda today with Ken Brittain is, again, Principles of Unit Testing and Designing for Testability in our 4-part series. And with that, Ken, I will want to thank you for your leadership today, and I'll pass control over to you right now.
Okay, well, thanks for inviting me. As Roger said, I am a programmer. I've been a programmer for pretty much my entire career. Right now I'm working on an application that is a large government project. We took over the maintenance of the project, and one of the things that my team has been working with over the course of this past year is rolling out unit testing across all subsystems so we can get better quality in our deliverables to our clients. So we'll begin. I'm assuming some level of familiarity with JUnit, but we'll work through that. So we'll start with JUnit. JUnit is a library for testing Java code. That is simplest form. It's a framework. In terms of unit testing, what I work with, we've come across many different terms for a unit test. So for this discussion, we're going to deal with a unit test as code testing other code in terms of classes and its intention. So there's other places where I've worked and been, and unit tests deal with recording things, paper documentation, but for our purposes, a unit test throughout this discussion is referring directly to the JUnit library and the code written in that framework. One of the things I want to bring out that we do is a unit test is part of your product. So it gets checked in with your code. It lives in version control. It changes along with the code that it is testing. It's maintained like production code because the unit tests themselves are part of the product. They don't ship with the product, but while in development, you do a build, you're getting ready to deploy, the unit tests are your guide to give you the confidence of the final product. You can test all you want. We call it regression testing from the outside in, but a unit test from the Java code, from the bottom up, is giving you that confidence level that what you turn in for a production build or for another environment is good code. So the unit tests themselves are going to be first-rate citizens in your project. There's a tendency to think about unit testing and it's done after the fact. It's something you just put in because a manager wanted, so-called quality, and that's not the case. If you're using unit tests, you're using JUnit, you're writing your code, it is a first-class citizen. It's part of your product. If somebody is writing code that breaks a unit test, well, then they own that unit test and they better fix it, because you wouldn't ship a piece of your product with a known defect that's going to cause major issues. But with a JUnit or other form of unit testing framework, people will ship with broken tests, and that's just not acceptable. So JUnit is a testing framework, and it definitely helps you write better code. We're going to be talking about JUnit 4, which uses annotations, the annotations language feature of Java. Previous versions of the library were built using a convention pattern with, methods were prefixed with a test keyword, things like that. You derive specifically from specific classes in the framework to get the functionality that you need, but the newer versions use annotations for getting its point across to the development environment. We'll look at some code later to show that.
Yeah, and Ken, I certainly can applaud you for your comments about testing in general, because many of our customers do, or many in the industry, wait till just some functional testing at the end, and hope and wish that all the quality has been built to that point. But that's the key point: is how do you don't invent quality in the testing phase. You are designing and building for quality earlier on in the life cycle, and doing this type of unit test is one way to do that and save development time and rework time and improve the software delivery life cycle overall.
Exactly. When I took over the team that I'm on now, I don't want to say I fought with our management, but our management definitely understood that a schedule as defined needed to be expanded to include this extra work, because that was one of the things. We have an existing product. The customer expects various features and functionality to be implemented over the course of time per their request, but we can't regress and break things. So we can either rely upon, like you said, more functional testing, regression testing from another division, or instill the quality in the product from the beginning ourselves. So we do have some overlap in that we're writing tests to test features, calculations, algorithms that then appear, say, on a web page, and then the integration team is then testing those features from the outside. But management, looking for that quality, they bought into it, and without their support, we would have never done it. I mean, up until this point, they didn't exist. These unit tests were not there. You definitely had some quality issues. So you need that buy-in, and they did, which was great, because it made it a lot easier.
Yeah, and that's a great point. It is a negotiating point, as obviously if they dictated it and said that's it, you wouldn't be doing it. Exactly. So you were able to negotiate that out, probably through some either cost justification or schedule justification on avoiding some of the pains down the road. Any idea what that looked like for this particular case, or did you come in after that?
Well, for this, when I worked on the product, so I knew we had various quality issues.
Yeah.
But our contract is such that we're rolling out evolution projects, but the client obviously doesn't want to see any regressions, and if you have a regression, it just looks bad. I mean, that's the bottom line. So management said, we don't want any more regressions. Well, if you don't want any regressions, then you either have to, double the size of your test team and hope you catch all the problems, or give us more time to develop, and we'll ensure that what we develop passes the test.
Yeah. that negotiating, by the way, there's a really funny YouTube video out there from, I think it's Unified Process Mentors, but it's I want to run an Agile project, and it's all his justifications for wanting to run an Agile project. I'll post that link in here as well. I think that's a pretty funny, entertaining one to look at, and is certainly related to some of the work we're doing here, as well as the Agile Transformation Group, also on DeveloperWorks, which I'll post a link for. I did want to just point out one last thing, Ken, before I let you continue, is that today's recording, everyone's line is muted until we'll open up for questions later. If you have a burning question that you want to ask now, post that into the chat window on your right, and I'll interrupt Ken, and then we'll open up the line later for Q&A. All righty? Thanks, Ken, and carry on.
And now we're going to look at code. All right, so here we have what we're talking about in using JUnit with the annotations. You can see I have 4 unit tests in here, or 5. One of them is ignored. One of the things I like to do is drop a template at the top of the file, which is the first section, the when expect, arrange, act, assert, and I just put the ignore tag on it. And I leave that on top so I can start copying it around. One of my formats that I use is this when expect structure. Other people can come up with their own. It doesn't matter what format you use for a test. It doesn't matter what conventions you come up with. You can spend an entire day reading the various arguments to and from various naming conventions, patterns, things like that. You just need to come up with something that you or your team feels comfortable with. My personal preference is the when expect method. So you can see I have a, when this is supposed to happen, expect this other thing to happen. And for me, that works best. So I have an example down at the bottom here that one of my colleagues likes to do, and he's on a different project, so we don't conflict. But he likes very long, descriptive names for his unit tests. And, it can go either way. You just need to pick something that you feel gives you the best for what you're doing. But you can see when we talk about JUnit 4, we're using annotations. I'm not sure if everybody has experimented with that before, but you can see, the @ test is marked as a test. And that causes the unit test runner, in this case I'm using Eclipse, but it's the exact same display for RAD. The test runner loads the class, looks for the attribute or the annotations, and it runs each method as a unit test. The unit test is like a mini main method. The runner will create a new instance of your class, and then it will call that method to run the test. The result of the test depends upon if any exceptions are thrown or if any of the assertions in the test passed or failed. One of the things, obviously, you want to go for is for all of your tests to pass. On our project, we have, many hundreds of tests that could fail at any time, but when we run them from a build, everything must pass at all times for that build to work. If something breaks, the developer needs to take a look at it, figure out why it broke, and move on. A lot of times, our system is bigger, so there's interdependencies, and a developer A might change something that developer B didn't intend. And in most of those cases, the developers themselves didn't run the test. They're waiting for the build to run the test to find the error, and that's just another issue that we're trying to get through, coming from a development group that didn't normally run unit tests as part of their life cycle. They're not accustomed to running your tests early and running them often. I mean, a lot of people talk about shipping your code early and often, but you need to write your tests and run them all the time. One of the things, the current project we're working on is changing the data layer for a specific web application. So rather than going straight up against some tables, creating SQL queries to do various operations and return some data objects, which is what we were requested to do, took the team down a different route where we're actually creating all of the unit tests for our data for each page before we even connect to a live database. In my experience and my opinion, it's a better method to go through, because then once you actually connect to some live data and you begin doing some of that work, everybody's going to notice the difference. You're not spending your time spinning your wheels. You've already written your tests. So in the first test that we have here, in the when missing char, expect exception, this is just a sample unit test that's testing whether a string actually has a character in it. You can see that I'm expecting it to throw an exception, okay? And that's noted in the annotation. It says I'm expecting an out-of-bounds exception to appear. You can see we create a string, it's empty, and then I go get that string. There's nothing in the assertions clause, because by that point we have already failed. You can see in the next example, when missing a char, expect the test to fail, that test, if you look over in the test runner on the left-hand side, which if you're using RAD and Eclipse, that should be your best friend. Normally it comes down on the bottom. I move it up to the side to get that view, so that anytime you want, you can just hit the button, rerun your tests, and find out what's going on. In this case, I was expecting this test to fail for this example, because it's the same as the example above it, but as you can see, we're missing the expected clause on the test attribute. So an exception is thrown in a test. The test itself fails. There's two ways a test can actually fail. One is, in this case, that the actual code being tested behaves unexpectedly. The other way is that a test itself runs in the assertion that a specific property or condition, as you can see in the final one, failed. So in both cases, we have a test failure, but for different reasons. One is we got an exception flying out of some piece of code that we either didn't know about or did not expect to have happen at that point, which causes a test failure. You can immediately address it by either fixing the test or fixing the code. In the second case, this test does work, but if I had changed this to a 1, you can see I have an assertion failure, which is different than an actual test failure. The test itself, yes, did fail because the assertion failed, but the unit test itself worked. In the first case, the unit test itself failed. And the difference being that when a unit test itself fails, the code doesn't work. When the unit test runs and the assertion fails, the unit test is working fine. It's just that the condition you're testing is now failing. And that's what we want to get to, where the actual unit tests themselves do not fail. We have that, when I say we run our unit tests, none of the unit tests fail. That means everything works like the second case. You either have it, the unit test passes, there's no assertion failures, so we want them working, we want the code running. They may fail because the assertion of what was supposed to happen didn't happen, but the actual code of the unit test itself worked just fine. So, I mean, obviously it's still not a good thing to have your unit test fail on some assertions, because that means obviously your code has some issues, but every unit test itself must run through completion. Now, if you look back, I have a section at the top called Arrange, Act, and Assert. It's a general pattern used. Like I said, you can read about this online. I'm just going to throw it out there because that's what my team does. Arrange, act, and assert. There's 3 sections. The arrangement section, it divides the unit test up. So the first part is where you're actually arranging for the unit test to be run. You can create objects, do anything you need. Later on, we'll see how we have mock objects that'll help us run our unit tests with more isolation. But once you go through the arrangement, setup of your unit test, you're then going to jump into the act section. This is where you carry out the meat of your test. This is if you're testing a method. If you look at this example, you can see I'm using the char act command. So in this example, that is the method that I'm testing. I'm testing whether it itself works or not. And it does, but you can see the expected exception at the first example right here. The test itself executes fine. The exception that is thrown is expected to be thrown. So the test passes because I get that exception. The failing test down below, it just fails completely because the actual code is wrong. And one of the things that we'll do on our programs, we're testing every public method that is externally callable, usable by other parties, and other parties are other developers on the team. We need, you're going to test the individual methods for correctness. Do they follow everything they say they were supposed to do? In our first unit test, the char act command said, if you request a character that is not in bounds, you're going to get an index out of bounds exception. So we wrote a specific test, or I wrote a specific test in this example to test that, and it does come true. The same thing happens with your applications. We're going to start looking at a simple address DAO and how it connects to various things. So
and DAO is your data access object, I guess?
Yes.
And what database are you using behind that in your production environment?
In my production environment, we're using DB2.
Okay.
There we go. Okay, so we talked about annotations. We talked about the ignore. Now we're going to talk about the class fixture naming. In unit testing, one of the things that comes up is how do you name your unit tests? I had talked about the arrange, act, and assert. But another thing that I found incredibly helpful is using the class method fixture naming convention. I got to go back to sharing.
And those annotations are really super helpful. I don't know how many people on this call actually know about those, but I think they started coming out with the EJB3 spec, if I'm not mistaken.
Right.
Or the JE3.
Annotations existed before that, but EJB3 kind of embraced them fully. So previous to an EJB3 scenario, if you wanted to create an EJB, you wrote a series of classes, support classes, doing kind of infrastructure type code. You had a home interface, things like that enabled the technology to work. Using annotations, it's kind of writing code for you. The compiler can inspect various things. We're doing this at runtime with a JUnit runner, where we give it just a normal class, and it's looking for the annotations to find the methods that it needs to run. If you don't annotate the method, it doesn't get run. It's not part of the test at all. So annotations are a helpful feature. They're used a lot more, I'll say, in modern, current implementations of Java to get around writing a lot of support code or using naming conventions themselves. The previous version of JUnit, the JUnit 3, if you wanted a method to be run as a test, you had to make it a public method. You had to begin it with the word test, all in lowercase. That was the indicator that this method was going to be a test. For right or wrong, it worked. But now with annotations, you can just flag any method. What that gives you is now the ability, as I mentioned before, to discuss various ways you want to name your methods. Previously, you would have to derive your test case from an object called test case. Now, just by having annotations, the class itself is implied to be part of the test fixture. One of the, just a general naming guideline that we have on our team, all test cases, an object that has tests in them, is called a fixture, a test fixture. And I believe that's just taken from the literature on unit testing. They call them test fixtures. So we decided we are naming our classes, with the fixture. You can see here I have class method fixture as the sample. And you'll see other ones marked with, from other projects, they'll name theirs as tests or unit tests. The reason why our team decided upon class method fixture is you can see in the Package Explorer over here that if you begin your unit test class names with the name of the class you're testing, then the method you're testing, and then the fixture, they'll start grouping your classes together in the tree. We decided we have, the class name, method name, then fixture. If you start including all of your unit tests for a particular piece of code into one single file called, address, DAO, JDBC unit test, that file gets very, very large very, very quickly. Our code is part of our product. If that file was, like anything else, we would need to refactor it. This is the way we came up with refactoring so that it ties everything together. So now the file name is giving you an indication of what is being tested. I know in this example that the create method is being tested on the address, DAO, JDBC implementation. So from the naming perspective of your files, you can start to get a feeling for what's going on in the test.
And Ken, one of our callers today from Canada, Sean Evoy, he reminded me here that there are some additional enhancements to RAD to support the JUnit experience for our customers. He can talk about those a little bit later if
Sure.
you don't have any of that on the agenda today. So
for my example, I'm using Eclipse at work because I'm home today. While we're at work, obviously we use RAD for all of our development. So it is kind of mappable, but the RAD features are definitely more robust. So we can definitely take a look at that after. Okay, so we're going to move on now to dependency injection. We're hopefully, some of you have at least heard of lately, the concept of inversion of control, where you have a class, you have an object, and the object itself is not going to drive what it needs to do. Any dependency that it has will be given to it. We like to say it's injected into the object. You can look at this class here. I did a default implementation of right here, the address DAO. The address DAO is just an interface. It has some series of methods used to access data. Nothing magical about it. You can expect it to go out and talk to a database. At this point, it doesn't do anything but define the methods that it needs. Now we move on. Here's a simple, non-working, mind you, but a simple implementation of the DAO, which is, again, the data access object implemented in JDBC, meaning it's going to use the standard libraries to connect to a SQL database and process various objects, which in this case is the address, just as the example. So this class itself, this implementation, has a dependency upon SQL, right here, JDBC, the Java Java connection class. So my client class here, the address DAO JDBC, accepts this dependency as a constructor argument. Operations in this client are going to use this interface. You know, down here we have create statement to do various options. This class knows nothing about the database other than the interfaces that it was given. So, and that's important because when you're doing this kind of work and you're separating out your classes in terms of, we'll talk later about separation of concerns, where you're dividing your system up into layers, a presentation layer, a data layer, a business layer, service layer, whatever it is, they're grouping together classes so they can behave, they can be refactored, they can be tested together. And that's the important thing that we're going to start looking at, that we're using interfaces to express dependencies on any external system, and then we're going to have those dependencies, they call it dependency injection, because in a bigger system you'll use tools that we'll talk about later to manage those connections for you, to create your objects that are fully instantiated with their dependencies. In this case, the dependency is that single JDBC connection. So this dependency is going to be injected into our class. The class doesn't know anything about how it's implemented, which is what we like to do for unit testing. So if we come down here to this file, we can see now we're going to write a unit test. And this unit test is using what we call mock objects. A mock object is an object that implements an interface, but the implementation doesn't do anything except record what has been called on it. So we can use that recorded state, that expectation of what we need to be done, and then assert that it was done. So if you look at our first unit test, we're creating a mock object for that connection class. That connection class is implemented in your JVM. It is available at runtime, and it would connect to an actual physical instance of a database or something very similar. In our unit tests, because the unit test, you need unit test to run fast, in isolation, one of the things we're doing is we're creating an implementation of that code that does not really do anything except record the calls, the parameters that were made upon it. This allows us to execute our unit test without any physical connection to a database. I mentioned before that my team now is writing a database layer for an existing application to go from Oracle to port it to DB2. So we're writing a series of objects. We're using exactly this. Obviously, the objects would be different, but the concepts are exactly the same, where we're testing that data layer, that it outputs exactly what we expected before we even connect to our DB2 instance to validate anything. So, I believe our code will have a, very good confidence factor in what we turn in to our first development environment for integration type testing. But you can see here, so just from a unit test perspective, that we have our mock JDBC object, which, again, another convention that we use on our team is if you have a mock object, you're prefixing it with the word mock. That way people that are looking at the unit test don't have to think about it. They know that that is a mock object and there is no way that could be mistaken. For a simple unit test like this example, it's a few lines of code. You wouldn't actually, or you shouldn't be confused by that. But if you have a unit test that is a couple pages long of code where an arrange section up on top is not visible where you're doing your acting because, some unit tests can become quite involved, it helps keep the code much clearer. So you can see now the address, DAO, JDBC implementation takes the mocked object as its parameter, just like the code that we wrote wanted. In this case, we just have the test fail because we pass in null. But if you look down below to the next section, we're actually going to be doing something with those mocked objects. So we create the mocked object for the JDBC connection. We pass it into our DAO. Then our DAO down here in the action is actually going to call the create. Now, we know because we wrote it that the create section or the create method, we know what it needs to do. We know it's going to create a statement. We know it's going to execute that statement, and it's going to return, the value of that statement. We can go look at the actual code, which, like I said, this is a sample, so there is no real SQL here. But these are the steps that you would take to test something like that. So getting back here, so the JMock is the library we use for mocking objects on our project. One of the classes in there is called a mockery. A mockery is that record playback feature. You can see we use the mockery to create the mock objects, and now we're setting up expectations about how those objects are going to be used. As remember, they're just interfaces. They have no real code behind them other than the code to do the record playback. It's not going to execute the functionality that you need. We're not talking to any real database. So what I'm saying here in this instance is I'm going to use my mock JDBC connection, and I'm going to create a statement. This will be called on my mock object, and it will return a value, and that value will be the mock statement. So I've mocked a database connection, and I've mocked a JDBC statement that I will use. And I'm saying, again, that my mock statement, I know I'm going to execute this update with any type of string. At this point, I'm not concerned about the correctness of the SQL on the project I'm working on. The correctness of the SQL does matter, but for this unit test, it doesn't matter at all. And then we're going to return a value of 0, indicating that we did actually create that.
And just a time check, we got about 20 minutes left for today. And of course, this is a multi-part series, so we can always continue next week as well. But just a quick time check there for you. Okay.
Yeah, because we got to finish up with mock objects. Or now we're talking about expectations. So one of the things that we're doing by using expectations are we're testing the behavior of the code that we're testing. I talked about before that code, the unit test code is a first-class citizen with your project. And here's why. Because we know how our unit tests will function because we wrote the code. So they are intrinsically entwined together here so that if you change how the create method works, and you no longer do an execute update, your unit test will fail. In this case, it will fail down here when we assert that the steps that we wanted actually took place. So you're testing, in this case, the expectations of an implementation of something. You're not testing the results of that implementation. If you look at the actual create class or the create method, it returns nothing. In our example, you call the method, you're going to create this object, and there's no return value because we assume it works unless it fails. If it fails, we'll get an exception, and there should be tests to test that. You can see the next one actually does that. We go through the same setup. We set the same expectations, except instead of returning a value that it worked, our statement is going to throw a SQL exception. Okay? Now, we know in our code that we're going to catch a SQL exception and rethrow another exception that we need to use on our class, and that's the example DAO exception. So setting up these expectations of how your code is supposed to work, and then going through acting upon that code and asserting that it worked or didn't work will give you whether or not your unit test passed or failed. We've done this multiple times. You're going to test each path through your code. We passed in null, we passed in a valid object, we passed in an object that shouldn't be created due to whatever validation concern. We can mock out that the database throws a SQL exception. We can mock out that the database is not connected at this point. You can mock out anything using the mock objects. One of the things you see is that we have repeating sections of code which need to be refactored. So another thing we've started doing is creating base fixtures, just like you would in any other project, for your code. And in this case, for the address one, you can see I have here our mock objects to handle various things. Now, just like any other class, we're extending it, we're making our fixture move on, and we've removed a lot of the repeating code in our tests. Our tests got cleaner. So now if you're looking at those same tests in this newly refactored class, you're going to start looking at the arrange, the act. They're more concise. You're looking at the expectations as much. You're not looking at the setup of the specific test as much. And that's important because your tests are going to grow. This is an example that tests 5 methods for one method. I don't know. It depends upon the complexity of your validation, because one of the models that we've chosen is a unit test a specific unit. That's one thing. We don't have multiple tests in one unit test method. Why you want to do that is because if a unit test fails, you want to know why it failed. What did it fail on testing? If you're testing multiple parameters in a unit test and it failed, now you then have to go in and debug your unit test. Trust me, that's not what you want to be doing. That's not much fun. So we're using expectations. We're using JUnit. We're using the annotations to test things. One of the things that we've come across with this is there's a lot of work in setting up your expectations. You have to know what certain things are going to do. So at various points in our development, we also use what we call dummy objects, which I'm sure people have used before. And a dummy object does exactly nothing. It is a default implementation that just goes through your code and provides a working interface. In this case, if we were going to use the address DAO for some operations in another unit test, we could provide this dummy object, which doesn't really do anything, but compiles, it doesn't throw any exceptions, and gives us an expected result. In our case, if we called create, we passed in an address, it would just work by not throwing an exception. So I don't know if you necessarily use this in your unit test, but we use it in conjunction with unit tests to get around various aspects of a system that perhaps we can't mock for a number of reasons. technical and or dealing with the language itself. One of the things we'll get into next time with the refactoring is mocking a static method in Java is very, very hard to do. So you need to either write a lot of code to get around it, or in another case, create a dummy method to provide some default implementations of things so that you don't have to jump through the hoops of the language because your original project was written in such a way that it wasn't testable at all. And that's one of the things that we've come across as we're going through our project. It was written close to 8 to 10 years ago that the project was written in a time when testability, when refactoring was either just coming out to be discussed or it didn't even exist. Annotations were not of concern at this point. Our classes were generated by some custom tools which limited their features. And now we have to go through, add back in that quality via the unit testing. And we're writing a lot of these for every single bug that we fix and for every single project that we implement. We have 2 developers for each. One developer writes the code, the other developer writes the test. And we go through in a fashion where they work together to get that code up and running a lot quicker than normally expected.
Great. And okay. Yeah, I was going to say if we can move soon to Q&A mode, that'd be great.
Sure.
If you want to finish something first, that I think we have a couple minutes to talk about that, and then we can do Q&A. Yeah.
And the last thing we were going to talk about, we were going to go through an example, but we can just, one of the things that, if we're writing new code that we find extremely beneficial, that a unit test, the big thing now is called test-driven development. Test-driven development says you write your test before your code. And that's really half true. You have to actually write your first, if you have an object that you're going to be using, you obviously need to get some base implementation up. Not the actual implementation, but something that you can write a unit test against, even just an interface with a default implementation using a dummy type object. But the unit test is the first client of that. And that gives us a lot of design data feedback rather than designing the perfect interface and then giving it to somebody to use. We're actually using unit tests to be our first client. And making it that first client, we find a lot of issues with how things were implemented or the way we thought they would work, because the unit tests themselves exist before any other real clients start calling our code. It gives you that look and feel for your library or whatever you're using, and takes it out of the traditional I'm designing something, this is how we think it should work. This is more I'm actually using the code. And you find the naming convention issue kind of came out because we started breaking out our unit tests based on a method. Then they got lost in a large tree, and we said, okay, well, now we need a way to group things together. And you can either create packages and go down that route, but we actually wanted to have our package structure in our project and our test project mirror each other. So they have the same accessibility level, but it's also easier to find. So if I know I'm going to, package main JDBC, I can go to my unit test, main JDBC project, and boom, find the actual unit tests that correspond up. And then the class naming structure kind of falls out of that. And we wouldn't have had that otherwise without refactoring the bulk of our code. So is there, I guess we can go to questions now?
Yeah, if you want to advance to the question slide there, Ken, I'm going to open up the lines now. It's going to take me a second to do that. Hold on, please. If you have a question. I do know that as you're doing that, Jean-Louis Marchot also mentioned the RAD version 8 Red Book has an entire chapter on JUnit and testing, and has some great examples there as well. So thanks, Jean-Louis, for mentioning that. That's a very good resource as well.
Hi,
right,
this is Javier. Can you hear me?
Hey, Javier, thanks. I can hear you loud and clear now.
Oh, good. So I actually did all this a while back, and I found that one of the hardest things that we had to do was actually JUnit, JEE issues like EJBs. JDBC is a lot easier, right, because it's API driven. But JUnit with EJBs, we ended up going with OpenJPA to actually create all the database before, and then actually using OpenJPA, which we could use in a JUnit environment because it was outside of a container. Have you done anything with using JUnit and EJBs?
Okay. Our application is a J2E application, and one of the things that we do, because you do have an issue with testing the EJBs in an EJB container as opposed to, JUnit code level implementation. So we took the approach of we're using JUnit for all of our code level unit tests, and everybody that creates a project works like that. We've abstracted. You can abstract out a framework for, we test our actions, because we're using struts, so we can test the entire web tier without a web container. In terms of our EJBs, we have them broken down such that we can test all the classes being used in the EJB, but we don't test the EJB itself in JUnit because we want our unit test to run really, really quick. We don't want to have to fire up a container or mock out the entire container. So the approach we took was then to come up with another library that we use in C#, and we go in through the front door, because ours is a web application, that we use a regression testing. We use Selenium, and because it's in C#, we use the Microsoft test framework to drive those unit tests to take, we'll call it the end-to-end regression test. So we think, by testing the code in the EJB and then testing the result of the EJB, we're not testing the actual EJB implementation itself with JUnit, but we are giving it enough coverage.
I've used Selenium also, and it's a very good product. You might look at OpenJPA because it'll allow you to test EJBs outside of the container.
Okay.
And it allows you to create via EJBs all your data outside of the database in the actual embedded database, and it works quite well. It just takes a little bit to set it up.
Well, hey, thanks, Javier, and glad you could make to the web conference with the technical difficulties you had earlier. Appreciate that. Any other questions for Ken for this week's session? Again, we'll be coming back next week for part 2 of this series. 3 times. Ken, thank you so much. Any closing comments or anything we should prepare for next week?
No, I'd like to thank you for inviting me. Next week we'll be talking about more refactoring, so it'll be more code level stuff. If anybody has any questions, suggestions, or miscellaneous comments, you can shoot me an email. I'm available on Twitter, and thank you very much.
Excellent. Thanks again, Ken. Great job today, and thank you all for attending. These slides and the recording will be posted on the Good Design and Good Business group on DeveloperWorks, that link provided here in the early part of the chat session. Thank you all, and have a great day.